Okay, let's do this problem. A rocky quarterback throws a football with an initial upward velocity component of 12 meters per second. Let's first write down what are given in this question. Okay, so upward velocity is vertical velocity. Py is equal to 12.0 meter per second, and then vertical horizontal velocity component, which is Bx, which is uh, 20.0 meter per second, right? Ignore air resistance. We'll ignore the air resistance, of course. So first thing is number A. What is the target variable here? Uh, how much time is required to football to reach at the highest point? So time is equal to what? Right? Football with an initial upward velocity. So with initial upward velocity, football is thrown. There is vertical velocity and horizontal velocity. So concept is of course, a projectile motion, right? Its vertical velocity is given, which is 12 meter per second, and horizontal velocity is also given, which is which is 20 meter per second, right? This is horizontal velocity and vertical velocity. So how much time does it take to arrive at the maximum point here? After then it will come back, right? Maximum point, this point. So to find that time, we have velocity and we also have acceleration, because acceleration is because of gravity, which is 9.8. You know the relationship, right? The concept is projectile motion, and we know relationship between acceleration, velocity. Simply write down g, because acceleration is because of gravity, meter per second squared. What will be the formula? Acceleration z is velocity per unit time t, right? So if you calculate this one, calculate this one, uh, just simplify. You have to find a t. That's why t is equal to uh, by divided by c, right? T is equal to v is vertical velocity is 12.0 meter per second square. Z is 9.8. Let me calculate how much we'll get. 12 divided by 9.8. We should get 1 point something. I'm getting 1.22, which is 1.1 1.22 second. Okay, so this is the A. A. We get answer for A. Now in B, this one, uh, how high is this point? So you have to find a height. So to find a height, you can again use the equation that is applied for vertical motion. That is simply kinematic equation. Okay, so let me erase this one and write down equation for second one. B. B. So B. So vertical height, vertical height, yes, is equal to, or you can say Y. Okay, so let me write down Y. B, Y, vertical initial velocity into T plus half ZT squared, right? Half ZT squared. We already get T to arrive at maximum point. Let us see like this way. So if this is the projectile, it arrives at maximum point, and let us consider the motion from here to coming to ground, right? That gives you the height. Whether you you go from bottom to top or top to bottom, that gives you the height. That's why let's consider motion from here to coming down, right? So initial velocity will be 0. At the top of the projectile motion, we know initial velocity is 0, right? So we can equate this one 0. So height is equal to then half 9.8. From the previous one, we get the time to arrive at the maximum height, which is 1.22. 1.22 is equal to uh, 9.8. How much is that? 9.8 multiplied by 1.22 divided by 2, right? Which is getting something like 7.3, 7. 35 meter. Okay. Let me do it again. Check it again. Okay. Whether we are correct or not. 9.8 divided by 2. 2.9, almost 5 into 1.22. And it is different value. So this is not a correct value. This is 5.98. Okay. So this was meter. Oh, we forget something here. Yeah. That's why this value should be into 1.22. We are correct there. Okay. So let me erase this one and get 7.29 meter. Okay, so this is the maximum height attained by that football. This is part B. Now going to part C, which is uh, finding how much time, that is total time, is after it is thrown, is required for the football to return to the original level. It means football was thrown and getting original level is this level, right? So their time will be just twice of the time required to get it at maximum height, which is, so to get maximum height, it was taking 1.22 second. So total time t will be 2t1, right? Because from going to here, it takes time t1, and from here to bottom again t1, same time, right? Exactly same time. So which is 2 into 1.22. This gives you about 2.44 seconds. Okay, so this is the total time taken by that football to come to the ground after launching. Now fourth one, which is D, I think it is how far has the football traveled horizontally. That is the horizontal range R, or you can simply say X. Let us say X. Okay, so you need the horizontal velocity, which is the X component, and total time T. So what is the X velocity? X velocity is given here. So this is 20.0 meter per second into what is total time? We just calculated, which is 2.44. If you multiply 2.44 with 20, you will get something 48.8. 48 48. Let me write it down again. 48.8 meter, right? That is the maximum range that football can see. This is the maximum range, right? Or 48, about um, 49 meter. Okay. So finally, draw graphs for xt, xy, bt, and vyt graph for the motion. So if we look at this motion, what will we see? Look at here. If you look at the x and t along the x-axis, x position, what is happening? With time, always there is increase in x component, right? X velocity is constant. It is not accelerating. That's why with time, if it is time and this is the x distance, it graph will be like this one. Okay, so we don't need something like arrowhead. It is not a vector. It is just simply distance. And y will be, if it is y and if it is t, then it is projectile, right? This is actually the projectile motion is showing the y velocity of the uh, y position, the change in position in y direction of the projectile. Similarly, if you put the velocity along the y-axis and the time along x-axis, then you will get some line which is constrained parallel to t-axis. With respect to time, velocity of x velocity of projectile, which is football in this case, is not changing. It means it should remain constant, right? Straight line. And finally, if you put t here and the velocity along the y-axis, it will be something because it is falling down, right? Initially going up, then falling down. All the time, starting from here, acceleration is pulling it down. So it will be opposite direction. Okay. So these are the plots that we need